Hello students, welcome to the channel Chemistry is Fun. Today's video is about the calculation of hybridization in the central atom in various molecules. Okay, so let us start the video with a simple example, that is silicon tetrachloride SiCl4. Now the first step to find out the hybridization is we need to identify what is the central atom. So we have discussed already in the previous video about the criteria to consider the central atom. Central atom is such an atom which has got higher valency compared to the rest of the elements in the molecule. So here silicon belongs to 4th A group and has got 4 electrons. That means it can bond with 4 electrons at a time, with 4 other atoms at a time with the help of 4 electrons. Now other atom in the molecule is chlorine. Chlorine, though it belongs to 7th A group, it has got 7 electrons in the outermost shell, but it can combine with other elements only with a single electron. That means its valency is only 1. So silicon has valence equal to 4, chlorine has valence equal to 1. So silicon is our central atom. So write down the valence electrons in silicon, 1 in the form of cross, 1, 2, 3, 4 this way. Now each electron of silicon will be bonded with each chlorine atom in the molecule. So write it down in the form of a bond between X and Cl. Don't misunderstand that this X is some halogen or something. This is the electron present in the central atom. These are the 4 electrons present in silicon. Now the next step is to count the number of bonds present in the silicon. So this is the first bond, second, third and fourth. There are 4 bonds in silicon. When the number of bonds is equal to 4, that means the hybridization is sp3. So this way we can find out the hybridization of simple molecules. Okay. Similarly, if you look at another example like POCl3. Okay, POCl3 is the molecule. Now here we have two different atoms, not just chlorine, there is another atom, oxygen and phosphorus. Now we need to again find out the central atom. Phosphorus belongs to 5th A group or nicogen family. Oxygen belongs to 6th A group or chalcogen family, and chlorine belongs to 7th A group or halogen family. This has got 5 electrons as valence electrons. This has 6 electrons in the outermost shell. This has 7 electrons in the outermost shell. But the valency here is 5, valency here is 2, valency here is 1. Usually the valency can be 3 or 5 in the case of phosphorus. So obviously phosphorus has greater valency compared to oxygen and chlorine. So that is our central atom. Now the next step is to find out, write down the number of electrons in the form of cross. Okay. Now there are 3 chlorine atoms which are monovalent and 1 oxygen atom which is divalent. So each chlorine can form only single bond, right? So write 3 single dashes against the X electron. And now these two electrons together bond with oxygen this way. Now we need to count single bond as 1, single bond as 1, single bond as 1. Altogether there are 3 single bonds. And we need to count the double bond together as 1. So this whole thing is one bond which relates to number 4. So altogether in POCl3 there are 4 bonds which is equal to sp3 hybridization again. Don't get confused that when you write double bond like this, don't count it as 2. Just count it as 1. Double bond and triple bond together it is taken as one number. So when the overall number of bonds is equal to 4, hybridization is also sp3. So this way we can use this method for calculating hybridization in neutral molecules. Similarly, we can calculate the same for the cations and anions as well. So let us take one cation. Okay, let us take a simple example of cation like I3 plus. Okay, I3 plus is a cation. Now I3 is containing only iodine atoms in it. So iodine is belonging to 7th A group. It has got 7 electrons in the outermost shell. So write down all the 7 electrons. So in case of I3 plus, any one of the iodines will be our central atom. So 4, 5, 6, 7 electrons, we write it as for calculating the hybridization. Now, three iodines, out of which one is the central atom, and the remaining two iodines will be bonding with single electron each. Now, here we need to put a small thing in mind that there is a positive charge given here, single positive charge. That means one electron is less. You need to remove one electron from the existing electron. So you have to remove this electron. So there will be only 6 electrons. So 2 electrons are bonded. Remaining 2 as a pair you have to consider as 1. So that means out of 7 electrons, 6 electrons we have to consider because there is single positive charge, and 2 are bonded with iodines. Remaining 4 take it as a pair and consider it as lone pairs. That means there are 2 bond pairs and 2 lone pairs. Together the value is 4. Again the central atom's hybridization is taken to be as sp3 hybridization. Okay, this way we can calculate the hybridization for cations as well. So let us look at one more example for cation calculation, that is SF5 plus. Okay, this is SF5 plus. Now sulfur belongs to 6th A group. Okay, so that means it has got 6 valence electrons. Write down all the 6 in the form of cross. 1, 2, 3, 4, 5, 6. Now there is a positive charge, that means you have to remove this last electron. So that means there are only 5 electrons in the sulfur. Now there are 5 fluorine atoms. All the 5 are monovalent. So write down each fluorine with a single bond. Since there are 5, we just write it as 5. Now there are 5 bonds. So when the total number of bonds is equal to 5, then the hybridization is sp3d hybridization. Okay, this way we can calculate the hybridization for cations and neutral molecules. Similarly, let us look at the calculation for anions as well. Okay, so we have a simple example here, ClO4 minus. This is perchlorate ion. Okay, ClO4 minus. Chlorine, as we have discussed, it is belonging to 7th A group. That means it has got 7 electrons as valence electrons. Now write down 7 cross marks indicating the 7 valence electrons. So these are 7. Now what is the difference between the cation and anion? Cation, there was positive charge, we removed the electron. Anion, there is negative charge, we have to add one more electron. So now the overall electrons in the molecule in the central atom are 8. So each oxygen will be bonded by a double bond. So there are 4 oxygens, so there will be 4 double bonds this way. So as we have discussed, we need to consider double bond as a single entity. So there are 1, 2, 3, 4 bond pairs. So when the bond pairs are equal to 4, then the hybridization is sp3. Let us look at one more example, that is PCl6 minus. Okay, PCl6 minus. Phosphorus also belongs to, like it belongs to 50 A group, which has got 5 electrons in its outermost shell. Now write down 1, 2, 3, 4, 5. Now what is the difference again? There's one negative charge. You have to put it as, you write 1 electron extra. Okay, now there are 6 chlorine atoms. All the chlorines are monovalent atoms. So write down all the single bonds against 6 chlorine atoms. So the total number of bonds are 6. So the hybridization is sp3d2. How can you relate this number to sp3d2 or sp3 or sp2? You have to count the number of orbitals present here. When I write the number 6, there is 1s, 3p, d2. So add up the numbers 1 plus 3 plus 2, which is equal to 6. Okay, first we use 1s and p, then we use 1s and 2p, then we use 1s and 3p, then we use 1s, 3p and 1d, then we use 1s, 3p, 2d, and so on. Okay, this way we give the number and hybridization according to the requirement. Okay, hope this method is useful for you. We'll meet again with another method or another topic. Thank you.